Good morning, everyone, and thanks for joining us. I'm Ajay Anand, Vice President of Products at Kyvos Insights. And I'm here to introduce our main speaker, Arun Jinde from Verizon. Arun is a technical architect at Verizon, and he and his team have been a core part of driving Verizon's big data journey. So we started working with Arun and his team about 1.5 years or more ago. And the problem that they were looking to solve was, how do we get instant interactive access for our business users so that they can do BI on data that was at a scale that they had never dealt with before? And they tried various solutions before they spoke with us and had not been able to find a solution that could scale and perform to their requirements. So the problem that we were trying to solve, getting interactive access for BI on big data, is a problem that we at Kyvos Insights, that's our main focus, that's what we do. So we focus on how do you provide self-service, interactive, instant BI on data at massive scale. Which this is a problem that Verizon dealt with, and I'm sure many of you are encountering as well. When you connect from a BI tool to massive amounts of data, typically response time can be excruciatingly slow. And that's because you're trying to process a huge amount of data when a query comes in. So the way we address it is by building a BI consumption layer on big data so that now you can transform the experience for your business user. Arun is going to talk in a lot more detail about how they went about it, how the problems that they solved, their approach, and a lot of technical detail as well from what I've seen in the talk about how the solution worked for them. So I'll hand it over to Arun and take it from here. Please welcome Arun Jinde.
Sorry about that. I hope you guys can hear me. So thanks, Ajay, for introduction. And we've been working on a big data platform for almost like 5-6 years now. So I'll go over our journey and I'll try to solve some of the cases that we are working through here. So first, little brief of our company. Everyone knows Verizon. So we are Fortune 14 company in United States. We have 98% wireless network coverage and almost 100% fiber optic broadband in the northeast corridor of United States. So we have more than 150,000 employees, and we have customers worldwide. We have in consumer, small business, as well as enterprise solutions. So for today's topic, I will talk about Verizon's video usage analytics in the consumer world, so how we dealt that issue. So here are the topics that we will briefly cover. So first thing is I want to go over what are the challenges that we wanted to cover while we implemented the big data platform. Then what is our architecture for big data, and what is OLAP and why we need it, and what are the differences between traditional OLAP versus a modern OLAP on a big data platform, and how we use modern OLAP for interactive BI. So let's get started. So while we were designing the big data platform, these were some of the challenges that we wanted to answer. First thing, huge data volume. As you know, with a big company, we have tons and tons of data coming from multiple sources. Like we have data coming from applications, customers' households, their routers, their set-top boxes, and we also have data coming from external partners like Digital Smith or any other Rotten Tomatoes, so on and so forth. So we have tons of data coming in. So first thing we wanted to solve was we should have an application which has a good, which can store all this huge amount of data. That was the first thing. Second thing, the data, varied data sources. So as you can see, we have like these applications, a lot of them are batch mode. Now with all the evolving technologies, now most of these data we are also getting in real-time messaging. And as you can see, we deal with a lot of external vendors as well to receive the data, for example, segmentation data from Epsilon or WAD content data, like their metadata, the movie data, Rotten Tomatoes, so on and so forth. So we have tons of data sources that we have to interact with, external and internal. A lot of database systems as well, like we have internally SQL Server, DB2, so on and so forth. So we wanted to make sure our big data platform is elastic enough to make sure that we are able to consume all this data. The third part is real time. Now, we just didn't want to make it like a typical data warehouse where I will do B-1, D-1 or D-2 reporting. I wanted to make sure that my platform should be able to ingest the data real time as well as generate some real time insights in real time. For example, I want to know, let's say CNN suddenly goes dark. I don't want the customers calling my call center telling CNN is down. I should be able to message them in real time by looking at the pattern that, hey, CNN is down, don't call us. So, or maybe a set-top box is not behaving well. It is getting rebooted again and again. So I can able to push a message to my call center telling that, hey, this customer is gonna call because his set-top box is not working. So these kind of really business-driven real-time insights, we wanted to make sure we can answer this through my big data platform. The other thing, data access and security. So with Verizon, it's very critical that we make sure that we are CP&I compliant. We have put proper access controls around the data. It's not just about opening up everything for everybody. Then self-service. So now we know the platform is robust enough, so we can capture all this data, very nice. So, but how will we enable this to my business so they can make informed decisions and drive business? So that was the other critical need for my platform. Last but not least, we had a limited budget and we wanted to make sure we deliver it in a quick fashion. So how did we answer these challenges, right? So first, for the increased data volumes, we went with Hortonworks Hadoop infrastructure. For varied data sources, we went with unified data models, and we sat with the business and came up with standard KPIs. So we wanted to make sure that everyone sees the single version of truth. So all the marketing, the finance, the content, everyone sits together and come up with their KPIs to make sure that we are all answering the same business question. Third one, real-time aspect. So here, everyone knows by now, everyone has attended a lot of sessions yesterday and today. So we were one of the first users of NiFi almost 4 years ago. So we are big NiFi users. So our real-time ingestion layer is NiFi. So we do messaging through Kafka, real-time processing through Spark and Storm. And we also have a lot of Elasticsearch for our dashboard, real-time dashboarding and insights. For data access, like I said, it's very critical. So we have a hybrid architecture. Part of it is in cloud. Again, with CP&I, we wanted to ensure that only part of the data is in cloud, and we follow what security has told us. So part of it is cloud, but most of it is in prime. For self-service, we built pre-connected data models and OLAP solutions. So everyone uses the same same tables. Both my business or my IT teams use the same data for their business needs. And for cost, for this particular use case of video usage, because it is heavily CP&I regulated, we went with on-prem solution rather than cloud. So this is our big data platform architecture in a very nutshell. So as you can see on the left-hand side, we are getting data from set-top boxes. We also have something called Fios mobile app, which will allow you to stream data from your own mobile devices, Samsung, Android, so on and so forth. We also allow our customers to watch video through their laptops using tv.verizon.com. So you have that. And now the content providers are coming up with their own apps like HBO on the go or Watch ESPN, so on and so forth. So we are getting this data all across from multiple systems, and most of them are real-time messages or in small micro batch files. So all this data is getting ingested in real time. We're using our big data platform here. And we enrich this data with tons of other data that we receive from our own applications as well as external partner vendors as well. And you can see we generate tons of insights based on this data. And we are serving our marketing, content, finance, ads, all of these teams come together to see the same data as single version of truth. So some infrastructure things here. So we receive around 12,000 files per day in micro batch mode. So we don't have a schedule for that. They keep coming 24/7, 365 days a year. And we almost receive like 300 messages per second from these content provider apps. We also have a very complex metadata management system in our side, because we just don't maintain metadata from our own applications, but we also have to maintain metadata about the content that is generated from the content provider. So it's so we have a dynamic metadata management there. So this particular video usage platform is around 5 petabytes with 200 nodes. Now, so we told, like I said, we have all this data. Now how I enable this data to my business users? So we went with the OLAP solution for that, because not all the business users wanted to come to Hadoop system to do their own queries and all, and it also was like not efficient for us as well. So we went with the OLAP solution. So what is OLAP? Actually, OLAP stands for Online Analytical Processing. Here the data is stored in the form of a cube. So cube is nothing but a collection of measures and dimensions. So you can think about it like a table, which is a collection of rows and columns. So here we call it measures and dimensions. So measure is something that that is pertaining to a fact, which can be measured in numerical columns. For example, we have distinct customers, total duration, revenue, price, so on and so forth. So these can be my measures. Dimensions are facts regarding that event, which will describe these measures. For example, when did that event happen? Where did it happen? So like date, region, so on and so forth. These are my dimensions. So now once we have the data in the cube, I need to know how to fetch it. So we have a language called MDX, which stands for multidimensional expression. Using that queries, we can pull the data out of the cube. Now, why we need OLAP? So OLAP gives some very good features for us for self-service. So a couple of quick things I want to walk through why we needed OLAP. So most important thing is it will support multidimensional queries. For example, I want to know how many people are watching ESPN by month by their TV package and who have kids in their home. That's like I am asking so many questions in one shot. So OLAP is very good for that. That's one thing. The other thing, I want to do iterative data queries for my data discovery. So for example, let's start again with the same question. I want to know how many people watched ESPN in 2018. Okay, then I want to know by month what was my distinct account. Was there any seasonality involved? Was it high in January or low in February? If yes, what? So those kind of iterative questions we can answer quickly with OLAP. The other thing, slice and dice and roll down and roll up. So like I said, again, let's take the same CNN example. So I want to know how many people watch CNN in 2018. Then I will drill down to the month level. Then I will drill down to the day level. So I can see, is CNN being watched in the night, in the morning, on weekend or weekday? How is it? So all this drill down and slice up, these kind of things can be easily done with OLAP. Another very nice example is the side-by-side analysis. So for example, I have a new movie released. So how did it perform this week versus last week when there were other, how was my ward sale this week versus last week when this movie was not there? So this kind of side-by-side comparison analysis or pivoting functions, what you call, you can easily do with OLAP. Now, when we went with the big data, so we were looking at lots of OLAP solutions, right? So most of the traditional OLAP solutions, I think most of you might have heard SSAS and other stuff like that. Those are all single node solutions. So I have real problem with single node solution because I can only add so much hardware and so much compute to it. So after some time, I cannot scale it. So I had a real problem when even for small cubes where I was getting about 2 million rows a day, I was not able to use that with traditional OLAP. Another problem with traditional OLAP, I have to always move my data from my big data platform to here. So there is delay in processing, as well as I have to maintain multiple infrastructures for this traditional ones. So when we were looking for OLAP solution on big data, we wanted to make sure that the solution exists within the platform rather than going outside. So these were some of the, again, why we were looking for modern OLAP. So like Ajay had told, so we had evaluated tons of tools at that time in market almost 2.5 years ago, and finally we landed up with Kyvos. So this is a brief architecture how Kyvos works. So I'll spend a few minutes to explain what happens. So Kyvos consists of mainly two components. One is a OLAP engine, the another one is query node. So let's look at it in a little detailed way. So for when you process a cube, OLAP engine will submit a map reduce job to your underlying HDFS. What it does is basically it creates all the pre-aggregates based on your cube design for different measures and dimensions, and makes it into small cuboid files that stretches all across your HDFS data nodes. So, and your query nodes, which is a second component of Kyvos, each query node is responsible for its own set of cuboid files. And there is a replication as well. So if sometimes a query node goes down, the other query node will take its work. And this same information regarding the query nodes and its data is available to the OLAP engine. So that's what happens when a cube is getting processed. Now the next step, when a user submits a query to the to Kyvos that I want to know how many people watch CNN and so on and so forth, right? So OLAP engine takes that request, it knows which query nodes have this kind of information, and it passes that request to that particular query node. And the query nodes then go and fetch the data from the underlying cuboid files and apply any filtering or aggregation, and then send that data back to the OLAP engine. And then OLAP engine does the final filtering and aggregation and whatnot and presents it to the user. So you can see here, first thing, the data is spread across all my Hadoop data nodes. So I will get horizontal scalability, right? I can add as much data as I want. This cube size can be as big as it can be, right? I don't have any restriction on the size of the cube. The other thing is, as I'm adding more query nodes to this cluster, my queries will become faster and faster. I don't have any restriction that I can only do so much. So these were some of the main features that we were looking for our OLAP solution on big data. Now, so what did we do with it, right? So we solved for some of the biggest cubes that we were looking for. These are the, we are still looking for another one. I'm working with the product team, which is even bigger than this, but as you can see, right? So our live TV cube is, we receive, like when I say live TV, let me just start on the first one, on the live TV, right? So here we have around 6 million customers in on Verizon Fios TV network. So every customer has multiple set-top boxes on their households or multiple devices at their hand. So every time you change a channel from CNN to ESPN or ESPN to HBO, that's a session for me. It will tell, the log will tell me that this customer with this device watched CNN for 3 minutes or ESPN for 5 minutes. So every session is a record for me. So this cube is at the most detailed level. So we receive around 200 to 250 million rows per day. And we maintain 13 months history for this cube. So you can see, this is, we have a 70 terabyte cube size. We have 38 different dimensions. So some of the dimensions I can tell, like the channel name and who owns that channel. For example, HBO is owned by Warner Brothers and so on and so forth, right? And we have the lots of customer information, like whether he has kids, what is his package, how much, what is his household income, tons of stuff. So we have like almost like 30, 40 dimensions for each of these cubes. So once we process the historical data, after that we just have to do the daily refresh, which will just do the delta. So it takes around 20 minutes to process this cube, and when we are asking for any analysis on top of it, it takes around 20 seconds. So that's the right now that's the biggest cube that is in production. Now, what did we gain with this interactive BI, right? So now, first thing, as you can see, right, now my analysis time is really, the business users don't have to wait for days or months together to ask for a simple request, right? So they can go and process, request their things, and it will be instantly available. So we are basically giving them interactive or iterative data directly access to the big data. And we made sure that we enabled self-service to the business users. And we can also, like most of our business users had Tableau on their system, and they didn't want to move away from it. So this works very good with them, because they can directly connect from Tableau to Kyvos, and they can build their own UI. So there was no change there. So again, a couple of other things. We didn't have to move data out of Hadoop, and we didn't have to maintain a separate infrastructure again for my OLAP solution. So these are some of the advantages that we had with this solution. And how this is being used right now, our finance team uses this data all the time to make sure that the amount of money we are paying to content providers, is it really worth it? What is my user base? How much is it being watched? Is there any seasonality associated with it? So all this deeper analytics they can do with this thing. Second thing is the marketing team. They will use this data all the time and see how is their VOD working, what movies are working well, do we have to, what kind of offers are being used by the customers, do we have to tweak anything? So all these kind of things. Again, like our content team is coming up and checking how is this, what channels are being watched in different packages, so we can do any content optimization and so on and so forth. We'll quickly walk over how easy it is to build a OLAP cube on big data using Kyvos. So these are some of the steps that we have to do, all the steps actually. So very easy, it's all UI-based solution. You don't have to go to any server or anything like that. It's completely on app. So first step is registering files. So here we are just telling into my H catalog Hive table, what are my measures and what are my fact tables and what are my dimension tables. You just select them and you save them, so they get saved here on your, as you can see on your left-hand side, those are some of the files that we created. The next step is to create the datasets around those files. So this is a critical task. You have tons of data on your tables. Now with this operations, you are trying to do any filtering of unnecessary data. You can create more columns to your existing data. For example, you want to do any substring or any other data operations on your data, any filtering, any joins, all that stuff you can do within this data sets. The next step is building relationships. So here again, it's all UI driven. So here we are trying to define from the tables that you have decided, what is my, how are my fact and dimensions related? Like, is it one-to-one relationship, one-to-many, or many-to-many, so on and so forth. So this is how we do it. Now, building the cube. Here we are trying to define your measures and dimensions. What all your measures? For example, here you can see we have account count, set-top box count, duration, average duration, so on and so forth. And my measures are my measures, and dimensions are like customer, programmer bundle, so on and so forth. And finally, I process the cube here, so it submits a MapReduce job. So when you are, if you want to do a full process or you want to do incremental, you can do that. And finally, you build visualizations and dashboards. So that's it. So any questions, concerns? Kyvos, you can use their own UI to build your dashboards and visualizations, or you can use your native BI tools like Tableau or anything like that. So Yeah, yes, so once you So first, let's say you go with it, right? You already have historical data. So first you want to catch up all the data as a one-time process, right? So that you want to do it, right? So you will define your partitions and all that thing. You want to use a sliding window, whether you want 13 months, 26 months, whatnot, right? So you build that. First you catch up the data for whole time. So first time queue process will be time consuming. It might take like a day, 2 days, whatever, based on the data that you have. Once you have reached that, after that it would be only a daily partition. So you will only have to process the new data that comes into your fact table. Yeah. Yes, yes, yeah, that's what takes 5 minutes. Yes.
Your Kyvos execution engine operate on dedicated infrastructure, or is it
No, not
located with your
within the platform. Yeah.
located?
Yes.
And it does good with resource
Yes.
segregation, all that good stuff?
Yes. Yes. We have like primary and secondary OLAP engines and 10 query nodes. That's it. It sits with our existing Hadoop platform. There is no separate infrastructure. Yes.
Do you have any use cases where you use the data across the cubes?
Not right now. Not right now. Yeah, they are working for that. So Ajay, we have already opened that case where we want to merge cubes or we want to select between the cubes. So we already have that working with them. So yeah.
Similar question to you, like the qualitative data where you're doing the analysis of the text. So most of the stuff that you share was like quantitative, they're using aggregates and using cubes for doing the text analysis and something around that one.
No, no. We have the search data, so we are using that one, but not like NLP processing and all that. But we have built a cube for search, where our VOD team is very interested in trying to see how people are searching for VOD content and how they are purchasing it. So what are the keywords, how many letters they type, and what do they select, and where do they take it from there. So that we use that. Yeah. Yes.
How do you deal with training data? Like if you want to get like verifying insights.
Sorry, I didn't get the question.
How do you deal with training data? Like if you want to get verifying insights and have a dashboard with that.
Streaming data. Okay, no. So with the streaming data right now, right? Even though we get the data in stream, we only process once a day. We will ingest it and we have the data ready, but the queue processing happens only once a day. So yeah. But we have like our Kibana dashboards and all, which are critical, whichever are critical things that we want to take actions on. That is on a totally different platform, not on BI. That's a totally operational systems that we use. That we have Kibana and all that stuff, where we push the data to Elasticsearch, and we also have a lot of applications that are directly talking to us on Elasticsearch using their web service call. So that happens in a different scale, not using this.
So this cluster used only to build the cubes, or were there any other workloads?
No, it has everything. It is part of our big data
Okay,
cluster.
so it's all
itself.
done in one cluster?
Yes, yes.
Okay.
Yeah,
And you do not have any issues with running out of capacity
No,
or anything like that?
No.
The reason I'm asking is, right, typically in an organization as big as yours, they have, if for running their workloads or batch loads, they have a separate cluster, and for consumption purpose, they have another cluster, right, for business consumption. Because you don't want to run your analytics query on a cluster which is having batch workloads.
No, we are maintaining everything together. We just have created separate workloads for each, but they are all on the same platform. We gave separate priority queues for each, like analytical has a separate queue and ingestion has a separate queue and so forth, but everything runs on the same platform.
The challenge with that is, right, yeah, you can control this memory, right, using Yarn scheduler, but your network is still common,
Yeah,
right?
that's yeah.
So
But
this is-
like I said, for this particular use case, which is like the video usage use case, it's only meant for video usage. This particular platform was built just for video usage. So that's this nodes, all the data coming in, most of it, almost 99% of it is just for anything related with customer and video. It doesn't have wireless customers data or things like that. This, because of the CPNI issues and the video usage sensitivity, this was built just for video.
Okay, thank you.
Yeah. Thanks. If you have any questions, just send me an email, and I'll let you go for early lunch.